It's a good time to start our class. We are still in module 7 about project management, right? And we still work on the wedding example. So today we try to wrap it up so that you are ready with question 25 of the homework 3. So let me get started with the whiteboard. Throughout the work today, I hope you also have a piece of paper in front of you so that we can work on the we can do the work together. Okay, so we have module 7 about project management. Right, and the big topic that we talk about, we are still at, is the critical path method, or CPM, right? We learned this method because the knowledge that we learn during doing this method will help us to do scheduling. Right. So the example one more time is a wedding example. The wedding example on slide 40. So early on in this example, right, we drew the AON project network or the activity or node network. So I would like to draw it one more time here as a reminder for everybody to make sense of what we do. So the AON project network or network would go as the following. So the bride to be and the groom to be, they will need to select the date, right, which is A. Then they need to select the location, which is B. Then they need to send out the invitation cards to the guests, right? But then on the cards, we need to know the date and the location. So there is one arrow going from A, one arrow going from C, right? We need to know both the date and the location to print on the cards, to send them out, right? So there are two requirements before C. Both A and B need to be done before we do C, right? And then the activity D is choosing entertainment. It can only be started or done after A is already done, right? So there's another arrow going from A to D. And then we need to choose catering. To do that, we have to know the date. So there's an arrow going from A. And then we also need to know how many guests there would be, right? So that they can cook enough food for everybody. So there's another arrow going from C to E. And finally, we go to the wedding day where we have to have entertainment and food ready, right? So there's an arrow going from D to F, another one from E to F, right? So that's the logic, the nature of the relationship among the activities in our project. And there's one more thing that we can do here is we write out the completion times of the activities. So A takes 1 week, B takes 4, 3, C is 3, D 4, E 3 again, and then F is 0. Right? The wedding day is just one day, is not a week yet, so we call it as 0. All right, so that's the things that we did quite early on, right? So that we can make sense of the project. And now I would like to remind all of you that we already did the tally method. Let me move it down here. So last time we did 2 methods to find the critical path. The first method is called the tally method. Right. Using that method, we list out all the pathways, and then we find the longest to be the critical path, right? And the critical path that we found last time is BCEF. It is the longest pathway, so that we have enough time to squeeze all of the activities in that in that time window to complete the entire project. So that's the definition method. And we also we also attended the Gan Chart Method, right? So we draw the visual timeline, and then we try to slide activities to see which one is part of the critical path and which one is not, right? Then we also find the same CP, B, C, E, F. Any delay on the critical path will delay the entire project, or the wedding day will need to be put up by another week or two, right? So the clue to find the critical path is we try to move the activities around and see if we impact the finish date or not, right? If we impact the finish date, then definitely that activity is on the critical path. Oh, you'll delay that by 1 week, okay? Any delay on the critical path will delay the entire project. Okay, so either method, we would find the same critical path. There are in total 4 methods, right, to find the critical path. So today we would do method 3 and method 4. Method 3 is called the boxed AON network method. So it means that instead of the circles that we see here in the AON network, right, we're gonna see the boxes. A box will look like the following, as I mentioned earlier on Monday, right? A box would have 9 cells like this. In the textbook, they do the 6-cell box. That is totally okay. I just prefer the 9 cells because it looks more intuitive, okay? So in each cell, we would write out the name of the activity or the ID, identification of the activity. And then we write out how long it takes to complete the activity, right? And then at the top row, we would fill in the earliest start and earliest finish, right? When can we start it and finish it as the earliest? And at the bottom row, we're gonna fill in the latest start and latest finish. For that activity, when we can start that and finish that as the latest, right? So the top is the earliest, the bottom is the latest. And in between, we would find the select time, or ST, right? So again, the third method is called the boxed AON, project network method, because we're gonna replace all these circles here by these kind of boxes. So, so what we are doing next is we replace all of these circles by the boxes. Okay, so let's start that method. So it is called the boxed AON network method. It's just another method for us to find the CP. Okay, so what I'm doing next is I would mimic the picture that we have here in the AON network, right? And now instead of the circles, we would draw the boxes. So let's draw the first box for A. It would look like the following. right? Instead of the circle, now we have the box for A. For B, we draw another box. For B. So A again is selecting the date, B is selecting the location, right? And then C is come up with a guest list and send out the cards. So we draw the C here. We just try to mimic the picture that we have earlier, right? So that sending out the invitation card, right? So remember, to send out the invitation cards, we have to know the date. So there's one arrow going from A, and we also need to know the location. So there's another arrow going from B, right, to C. And then next, we need to choose an entertainment company. That is D, so I draw the D here. And to sign the contract with the entertainment company, you will need to know the date. That's why we have an arrow from A to D, right? And next, we need to choose catering. So we have another box for E. Like that. And to choose the catering, we need to decide on the date. So we have one arrow going from the date. And we also need to have another arrow going from the guest list, because catering means cooking, and they need to know how much food to cook so that everybody will have something to eat, right? So we have that E with the two arrows going to E. And finally, we have the wedding day. So the wedding day is right here. That's an app activity. And there are two arrows. We have to have entertainment ready. At the same time, we have to have food ready, right? So we need to preserve all the arrows that are included in the question or in the AON project network that we draw earlier, right? Okay, so each box will have 9 cells. And where do you fill in the first cells? The second cells will be very easy because it tells us how much it takes to finish each of the activities, right? So, for example, A takes 1 week, right here, down here 1. B takes 4 weeks, down here 4. C takes 3 weeks. D takes 4 again. E takes 3 again, right? And the app activity is only 1 day, so we call that as 0 weeks. So all these numbers that you see right now are the duration. How long, right? That's the duration. So what we're doing next is the following. We're gonna fill in the top row. And then later we're gonna fill in the bottom rows. And then at the end, we're gonna find the select time. And we keep the cell right in the middle blank. We will not fill in anything, right? Okay, so let me show you the first step here. So the first step is we need to go forward pass, go forward, or we do the so-called forward pass so that we can fill in the earliest start and the earliest finish dates as the earliest. When can we start the activities? When we can finish the activities, right? Where the earliest finish equals the earliest start plus T, right? We started today, it takes 1 week, we add with 1 week, then we know that we're gonna finish the activity at the end of the first week. So let's do that for A. A is a free activity, right? it means that there's no requirement before A. The bride-to-be and the groom-to-be can think about the date right away. So we can start a point at the beginning of time or at the right away, right? So we call that a 0. So we start at point 0, we add the duration of 1 week, then we're gonna finish at the end of the first week as the earliest. Remember, the numbers at the top is for us to find the earliest date, right? So as the earliest, we start at right away, and then we finish after 1 week. So by the same token, I would like to ask everybody to fill in the numbers for B. So what will be that number, and what will be that number? Please feel free to share your answer in the chat window. All right. So I already saw that from C, from Fallon, from V. Good. So you all agree, right? I hope other students see the same thing, right? So why cannot be 2 and 2? Because B doesn't have any requirement before it, right? It means that B can be started right away. Started right away means that we can start B right now or today. We call that as a beginning of the timeline or 0. And then it takes 4 weeks to finish B. So from today, we add up 4 weeks. Then we finish B at the end of the 4th week, right? So that number 4, that 4 right here means that we can finish B at the end of the 4th week. Okay, good. All right, so all right, so that's A and B are done, right? Let me clarify, okay? The numbers that we see here are points in time. 0 is a point right now, right? And 1 is the end of the first week. Or down here 0 and the end of the 4th week. The number down here are different. The numbers here are the duration, how long. It's not a point in time. It is how long it takes, right? So 1 week long, 4 weeks long. All right, so we already get A and B done. I would like to ask everybody about C. The second number is very easy, right? We just add with 3, then we have the second number. So the first number is essential. So what or when can we start C as the earliest? Right. So now that's the question. When can we start C as the earliest? And here's a hint for everybody. You have to keep track of these 2 arrows, right? To determine when we can start C as the earliest. I saw C answers already. Or C pay, right? Answers already. How about others? Do you see the same or do you see something different? Fallon is a little bit different. How about others doing? What do you think? So Sophia and VE. Okay, good. So maybe Fallon has a little bit slightly different answer, because now maybe the time unit is not very clear. So instead of talking about weeks, okay, to make it easier for you, sometime I'm going to talk about these times, points in time as the clock time. So in this case, right, we finish A at 1 p.m. We finish B at 4 p.m. Right, 1 p.m. here, 4 p.m. here. Then at what time can we start C as the earliest? Right, it is a point in time. This is not the duration. So we finish A at 1 p.m., we finish B at 4 p.m. Then as the earliest, we can start C at 4 p.m. Right? We don't have to wait until 5 p.m. because here we talk about the points in time. So I hope everybody sees that, right? And between 1 p.m. and 4 p.m., we have to select 4 p.m. to accommodate that 4. If we choose that point to be 1 p.m., then even though that 1 p.m. is good with that 1 p.m., right? But then that 1 p.m. will be in time conflict with that 4 p.m. We cannot do B and then we cannot do C and then start B, right? You have to finish B first before we start C. So that's why the number here needs to accommodate the numbers before it, right? So that's why the answer here would be 4 p.m. or at the end of the 4th week, right? So even though, oh, fine, but we finished B at the end of the 4th week. Fine, when we start, okay, so if we go back to the week units, then I would say the following. A is finished at the end of the 1st week. B is finished at the end of the 4th week, right? Then C can be started right away at the end of the 4th week. You can say at the beginning of the 5th week. That is fine. But to be consistent with the time units here, we have to say the same thing, right? So that's why here we will say we would start C at the end of the 4th week, right? Otherwise, we might have kind of different minds when we talk about different times here. So to be consistent, yeah. So we need to start C at the end of the 4th week, okay, to be consistent in the way that we look at the timeline. Is that good, everybody? Okay, good. All right, so C is started at 4. It takes 3 weeks. Then we would finish C by the end of the 7th week, right? Or like if we start C at 4 p.m., it takes 3 hours. Then we're gonna finish C by 7 p.m. Do you see the way to think about the time, the points in time, and the duration, right? So whenever you feel confused or something hard to think about, then please always convert it to the clock time. That's a trick to make it easier for you to keep track of the numbers. All right, so to make sure that everybody understand it, I would like to ask everybody about D. What should we do here for D? What is that point? Or in other words, when can we start D as the oldest? Okay, so I see several answers already, and possibly there are some disagreement among you, right? All right, so one more time. How do we figure that out? We have to avoid all the time conflicts, right? So D has a requirement before it, which is A. So we need to look at the A so that we can kind of honor the president's relationship for D, right? So there's only one requirement before D, which is A right here. So that's why we need to look at the end of A. We have to finish A before we start D, right? So we look at the end of A, which is 1 right here. So why after that we can start A, right? Yeah, A. Now, yeah, don't worry because we are still early on in the learning process, so it's okay if we miss something. Now we are more conscious about the arrow, right? So after we finish A at 1 p.m., then we can start D at 1 p.m. as the earliest. If you write out number 2 here, it is okay because 1 p.m. here and 2 p.m. here have no time conflict at all, right? But here we try to find the earliest date that we can start the activity. That's why as the earliest, right? It has to be 1, not 2, or whatever a number greater than 1, right? It has to be exactly 1 p.m. we can start D right away after A is done, right? So again, those are the points in time. D takes 4 weeks, so we take 1 plus 4, then we have the end of the 5th week, right? That's the end of the 5th week. Remember, last time we did the Gan chart. When we say 1, it is the end of the 1st week. When we say 2, it is the end of the 2nd week, right? And here, if we say 5, it is the end of the 5th week. Okay, to make really sure, I would like to ask everybody about E. Right, so what will be the early start time or start date of E? Let's feel free to think about it. Okay, so I see lots of answers already. And this time around, I believe you would all agree, right? Yes. Yes. Because in this case, right, now, remember, E is the the catering. We have to know the date. So there's 1 arrow from A. And then we also have to know how many guests that would be, right? So the requirement Y before E is A and D, A and C. So you need to look at the end of A and the end of C, right? The end of A is 1 p.m., the end of C is 7 p.m. So it cannot be 1 p.m. here, because even though 1 p.m. works with that 1 p.m., but then that 1 p.m. will be in a time conflict with that 7 p.m., right? So to accommodate both A and C, we have to choose the later date. So 7 here, or in general, we need to choose the largest value or the latest date, right, to write out as a start date for E. Let me interpret it in another kind of way. So even though we finished at 1 p.m., right, but we cannot start E right away. We have to wait until we finish C at 7 p.m. Then we can start E. So that's why as the earliest, we can only start E at 7 p.m. and not earlier than that, right? So I hope you see the logic why we have that 7 p.m. And because it takes 3 weeks, 7 plus 3, then we have 10 weeks here. That's the end of the 10 weeks. It's not 10 weeks long. It is the end of the 10th week. Okay, so that's the E activity, and the F activity is easy now, right? So when we look at F, there are 2 arrows before F. We have to accommodate. We have to honor these 2 arrows, right? So it means that we have to finish D and E both before F. In other words, when we finish the at 5 p.m., we finish the at 10 p.m., then we have to wait until 10 p.m. to start F, right? So we start F at 10 or the end of the 10th week. And it takes 0 weeks. So we add 0, then we're at 10. Right. So let me recap. What we have just done is we do the so-called forward path. We go forward by finding the earliest start date first, and then add up with the completion time, right? That's going forward right there to find the finish date, right? The earliest finish date. And then we follow the next arrow. The arrow also goes in the time order. So we go forward, follow the tracking along the arrows, right? So that we go to the next activity and also do the earliest start and then the earliest finish dates, right? So we by now we already fill in all the numbers at the top row. The top row is for the earliest dates, and we are done with those. In the second step, we will need to fill in the bottom row. So to do the bottom row, we would do the so-called backward pass. In the backward pass, you would need to fill in the latest finish date first. And then you would subtract the T from it so that we have the latest start date. Right, so the latest start date equals the latest finish date minus T. Right. So as a reminder, the top row tells us the earliest dates. The bottom row tells us the latest date. We also have the start date, the finish date, but they are the latest dates. Right. Okay, so it means that we now start from the end of the project and then we go backward to the beginning of the project, and that's why we're gonna revert. We're gonna trace the opposite direction of the arrows. And second, for each activity, we need to backtrack by the T. Right, that's why we have the subtract or minus T here to go kind of backward. So how to do this step number 2? The first thing that we have to do is we impose the following condition, that these two numbers must be the same. What is that, right? The first number on the top right here is the earliest finish date. So as earliest, we can finish the wedding by the end of the 10th week, right? That's what it says. As earliest, we can finish the project by the end of the 10th week. And the bride-to-be, the groom-to-be, they don't want to delay that wedding day at all, right? They don't want to wait for another week. They have to plan to fly somewhere for their honeymoon, right? Their honeymoon, so they want to keep the deadline strict at the end of the 10th week. So we impose a condition that we don't want to delay the project at all, right? The earliest finish date should equal the latest finish date. So that's the logic why we have these two values equal, right? Okay, so it means that they will try the best so that they keep the wedding date unchanged or fixed, right? Okay, so if we already know the latest finish, then we just subtract the time to know the start date as the latest. Remember, we already done with the top row. The top row is for the earliest. Then please disregard the top row, and only please pay please only pay attention to the bottom row, okay, where we find the earliest date, the latest start date and the latest finish dates. And between the two, we need to find the finish date first before we backtrack to find the start date, right? So it means that next we only look at the bottom rows. And again, please disregard the top row because we're already done with the top rows. Okay, so how to do the backward pass? We already have the end of the project. We backtrack a little bit, and now we need to go back to the activities, right? So one more time, we have to do things in the reverse way. Earlier, we followed the ABC order. Now we follow the opposite of the ABC order. We did F earlier, now let's do E, okay? So when we look at E, then we have to ask ourselves, where does E go to? E goes to F, which means that before we start F, we have to finish E, right? Or more specifically, before we start F at 10 at the bottom row, we have to finish E by 10 as the latest, right? So the number down here should be 10, so that we don't have any time conflict between that number and that number. This number can be 9, can be 8, can be 7, right? Because they don't have any time conflict with that 10. But here we try to find the latest date. So as the latest, right, we hit exactly 10 in this value. Okay, so we backtrack by 3 weeks, then we have 7 down here, right? So as the latest, we start E at the 7th week, at the end of the 7th week. and finish E by the end of the 10th week, so that we can start F at the end of the 10th week. So they will finish the party, and then by after that they will fly out to the honeymoon destination, right? All right, so that's the E activity. So please try for D. What are the two numbers that we should write out here for D? Please give me the end date first, the finish date first, and then go back to the start date. So what would be their time? The two numbers, right? Good. I see that you got it all correct. Good. So in this case, right, when we work on D, yeah, I see all the contribution. Yeah, you are all correct. Good. So in this case, we look at D. Then we know that D has to be before F, right? That's why we have the arrows right here. It has nothing to do with E, because when we look at E, D, the arrow goes here with the F, not E, right? So we trace along that arrow, and we know that we realize that D has to be done before F. And we want to start at 10 p.m. Then D has to be done by 10 p.m., right? 9 p.m. is okay because it doesn't have the conflict with the 10 p.m. But then here we try to find the latest date. So that's why we have to hit the limit, which is a 10 right here, right? So we write the 10 here as the latest. And then we subtract 4, then we have 6. Right? We subtract by 4 weeks, and we have 6. So by now, right, I hope you see the logic on how to apply this. And let's go back to C. C, when we look at C, right, then we see that, by the way, I just followed the reverse of the alphabet order. You can do any other things, but sometimes it is easier to keep track of our work by following the alphabet or the reverse alphabet order. So we have the C here, right? Then we realize that there's a, after C, we have the E. C doesn't go anywhere else, C goes to E. So it means that before we start E at 7, at the end of the seventh week, then we have to finish C at the end of the 7th week. I'm sorry, I should not point to that point. I'm pointing to the bottom cell here, right? Then this one should be 7, right? So we write out here 7. So we finish C by the end of the 7th week, so that we can start E right away at the end of the 7th week. Right, we have 7 here, by track by 3 weeks, then we have 4. Right, so I hope everybody sees the logic. And next, we need to find out for B. So what are the two numbers here, right? It is the same logic. Please try that for B. Okay, so Christopher already has the answer. Okay. In, good. Good. So I believe that everybody else also sees the same, right? In this case, we see that there is an arrow here. So it means that we need to finish B before we go to C. Right? C is started at 4 p.m., then B has to be finished by 4 p.m. or the end of the 4th week. So we write out here 4, and backtrack by 4 weeks, then we have 0. Magically, we go back to the beginning of time. You see that we reached the beginning of the project, right? So that's a good thing, because earlier we go forward, now we go backward, and then we see the beginning of the project. Okay, so how about A? You know what? I would like to say the following. A is the most difficult. This number right here is the most difficult number to come up with in the entire example. So please give it some thought, and then please share your take on this one. Right. Okay. So I see that from Ing, and then from Will, from Fallon. How about other students? What can you think of that number? I say it is the most challenging number in the whole math. Right. So what will be that number? At least we have two camps now. Somebody said 4, somebody said 6, right? So how about others? What do you think about that number? What number should we fill in here? Here's a hint for you. You have to keep track of all of the arrows going from A, right? Because that's the precedence relationship right there that we have to observe, to honor. So I see more here. Okay, so I see that now. Everybody said that before. Okay, you know what? You are all correct. That's a good thing, right? Because of the following. The logic is the following. We know that there are 3 arrows going from it. So A has to be done before D. Sorry, A has to be done before C, D, and E, right? C, D, and E. And we want to start C at 4 p.m. We want to start D at 6 p.m. and E at 7 p.m., right? Then between 4 p.m., 6 p.m., and 7 p.m., we have to finish A by 4 p.m. so that we don't have any time conflict with 4 and 6 and 7, right? If we choose this to be 6 or 7, and it is not the first time when I ask this to any other classes, right? Some people might say 6 p.m. or 7 p.m. It's okay because we're still learning. But if we put down here 6, then even though that 6 works with that 6, but then that 6 is in conflict with that 4, right? It will not work. So that's why we have to choose the smallest, right? Earlier we choose the largest when we go forward, but when we go backward, actually we have to choose the smallest value among the candidates, or the earliest the earliest dates among all of the candidates, right? So that's why it is 4. If you write out here 3, okay? If you write out here 3, then we will not have any time conflict. But because we try to find the latest date, right? So that's why we try to hit the constraint among 4 and 6 and 6 and 7, right? 4 is the constraint that we need to hit. So we write out here 4 as the latest. Otherwise, if it is a free number, then you can write out 3 or 2 or 1 or any things like that, right? But because we try to find the latest date, that's why we choose the minimum among these 3 numbers. Okay, so if we have 4 right there, we backtrack by 1 week, then we have 3 here. So A looks strange. If we look at B, we see that we go back to the beginning of time. But for A, we do not go to the beginning of time, right? So A is what? So if we look at the number, remember that we impose a condition that we will not delay the project. The wedding party will happen at the end of the 10th week. That will not change, right? But this number says that, oh, so by now it means that A can be delayed to the 3rd week, the end of the 3rd week as the latest, without impacting the wedding day at all, right? Because we already impose that condition that the wedding day will not change. So it means that A can be delayed by 3 weeks without affecting our project schedule, right? The end of the 0 week as earliest. Now, the point of time right away is 0, right? If we delay that by 3 weeks, it will not change the project schedule, right? So it means that A is not on the critical path, right? That's a suggestion right there. A is not on the critical path. A can be delayed, but to some extent without affecting the project schedule. And that extent, that limit is the 3 weeks, 3 weeks long, right? That we can delay A by. So in this case, right, we call A as a slack. We call it as a slack because we can delay it without affecting the project schedule, right? So A is a slack, and it has a slack time of 3 weeks. So the 3 weeks is a time limit that we can delay A by, right? So A, it means that A can be delayed by 1 week without affecting the project schedule, or A can be delayed by 2 weeks without impacting the schedule. A can be delayed by 3 weeks, right? But A cannot be delayed by 4 weeks, because if we delay by A by 4 weeks or 5 weeks or more, then we're gonna delay the project by another week, by another week, by another week, right? So the 3 here tell us suggest us of how much we can delay A by. So that's the next step. Step number 3, we will need to calculate the slack time of the activities. The slack time of the activities can be calculated as the latest start minus the earliest start. The intuition is clear. If we compare the 2 start dates, the earliest start dates and the latest start dates, then we're going to see how long we can delay that activity by, at most, right? So if we look at the A, we take the number 3, subtract the number 0, then the slack time is 3. Or equivalently, we can do that as the latest finish, subtract the earliest finish, right? So this time around, we compare the 2 finish dates. Then we take this 4, subtract that 1. Then we also have the slack time of 3. And it's not a coincidence that these 2 numbers are exactly the same. They must be the same. Last time I draw you a picture, let me remind you. For example, I have this pen as our activity A right here, right? So now if we slide it down, or it means that we delay A, right, by some time, then when you subtract the 2 start points and subtract the 2 end points, then the distance, the 2 subtraction must be exactly the same, right? So here it is the same, right? We subtract the 2 earliest start dates, sorry, the 2 start dates, or if we subtract the 2 finish dates, they must be the same. So the slack time either here or here, they must be the same. By the same token, I would like to ask the whole class, what will be the slack time of B? Okay, so what is the slack time of B? Fallon, Marco, you agree. I hope other students also agree. Right, Jaylin, good. Yeah, good. But not 3 minus 3. For B, you need to take that 0 out here, subtract the 0 up here. Right, that 0, subtract that 0. That 4, all equivalently, that 4 out here, subtract that 4 up here. Right, yeah. So earlier, so again, it means the following. That's the latest start that we can start B, and that's the earliest start that we can start B. So we compare the 2 start dates. We see that the slack time is 0. Or equivalently, right? We compare the 2 finish dates, the earliest finish, the latest finish. We compare them. Then we also have the 0 here. right? You have to take the bottom number, subtract the top number. What does 0 mean? 0 slack time means that we cannot delay B at all. Because if we delay B, we're gonna delay the wedding date, right? The bride-to-be, the groom-to-be, they don't want to be late for their flight for the Bahamas, for example, right? So they will try to keep B on time without any delay, right? So that's it is a suggestion that B is on the critical path, right? Because any delay on the critical path will delay the entire project. So 0 slack time means that that activity is on the critical path. A positive slack time means that for A, for example, A is not on the critical path, right? So by the same token, we do that for C, and we also see that it is 0 here and 0 here. Again, you would take the number 4 down here, subtract the number 4 up here, or equivalently, right? You take the 7 out here, subtract the 7 up here. Then we have the 0 and 0. So one more time, we fire another activity on the critical path. Okay, how about D? Everybody please try the D. Okay, good. Yeah, good. So in this case, we realize that we have another slack in our project, right? So for D, you would take that 6, subtract that 1, or equivalently, you take that 10, subtract that 5, right? Then we have 5 and 5 right here. So it means that D is a slack. In other words, it is a non-CP activity. And it means the following. D can be delayed by 1 week without affecting the project schedule. Or D can be delayed by 2 weeks without affecting the project schedule. Or by 3 weeks, by 4 weeks, or by even 5 weeks without affecting the project schedule, right? But if we delay D by 6 weeks, then the wedding date will be pushed down by 1 week, right? And then D will become part of the new critical path. Okay, so that's what we don't want it to happen, right? So in this case, we only want to delay A by 3 weeks at most, and then we delay D by 5 weeks at most. So if we just continue with the slack time, then we have that 0 here, that 0 here, right? E is another activity on the critical path, and F is another activity on the critical path, right? And now it's easy to find the critical path. The critical path is composed of the activities with the 0 slack time. So now we find out that the critical path equals B, C, E, F. So you know what is magical that we come back to the same answer as before under the tally and the Gan chart method, right? It is the same, B, C, E, F as a critical path. And if it is not the same, then maybe something is wrong, okay? So that's why it must be the same, because it is the same project. It is the same logic and concept here. So the critical path file in each way is going to be the same, right? So as a manager, by the way, because it is a critical path, I would need to draw these arrows to designate that as a critical path. So as a manager, we need to keep a very tight grip on the critical path, right? So that we can keep this time window of 10 weeks fixed. The A and D can be delayed to some extent. For example, if we need more resources to be focused on the critical path, then just try to keep the critical path on time. The A and D can wait a little bit, right? Without affecting the critical path, then they can be delayed a little bit. But then we have to have a tight grip, a very tight grip on the critical path so that we can finish the whole thing. in 10 weeks. But of course, we cannot delay A and D too much, right? Otherwise, we will delay the project. So that's the box and network method. As a quick recap, we do the forward pass to fill in the top row. Those are the earliest dates. And then we go back down and go backward, fill in the latest dates. And then we find the select times, and then we find the critical path. And as a manager, as a project manager, right? These are all of the details that you will need to schedule each of the activity. Now you know when to schedule B, C, E, and F, right? And then A and D, you also know the time window that you can schedule them into, right? Okay, so that's the thing that we learned from the box network method. It is a very detailed working out of the scheduling of the project. So we're done with the third method, and now let's move on to the next method. The next method is called the table method, right? So in that table, we don't have the visual cues anymore. We don't have the intuition that we see in this drawing anymore, right? So it's a little bit more abstract with the table method. But I would say that the table method is very similar to the box array method. All right, so the table method is just another way to find the CP. Okay, so in this case, right, we would need to draw a table, and then it's very similar to what you would do for question 25. In question 25, I ask you to do all four methods: the tally method, the Gan chart method, the box array method, and finally the table method, right? So you would need to draw a table that looks like the following. Okay, so first of all, in the first column, we have the ID. We have A, the date, B, the location, C, the guest list, D, the entertainment, E, the catering, and F is a wedding day itself, right? Okay, so that's the first column. The second column tells us the precedence relationship. So we call those as the IP, or it stands for immediate predecessor, right? Or in the daily language, IP means what has to come right before it. The first floor comes right before the second floor, right? I hope you see that logic. So the IP tells us the requirement right before the activity. Right before A, we don't have anything. A can go freely right away, right? B doesn't have any requirement right before it. Another dash here, and then C. I'm sorry, maybe some amber alert or the weather alert. I'm not quite sure. Somewhere in Southern California, we might have some serious weather alert. Sorry. All right, so A is a free activity. There's no requirement before A. There's no requirement before B, right? And C is sending out the invitation card, so we need to know the date and the location, right? So A and B come before C. And then D requires a date. So we have A, right? Before E or catering, we need to know the date. And we also need to know how many guests there would be, so A and C. And finally, before F, we have the entertainment and the catering, right? So those are the prerequisites or the requirement right before the activities that we are looking at. So that's the second column. Right? This second column is essential. As a project manager, you have to think really hard about this second column. Otherwise, if we miss it, if we miss one thing, then we're gonna have to go back and redo something, right? It costs money and effort and time. So the second column is very essential, and we have to think really hard about it. The third column is the time to finish each of the activities. So we assume that these times are kind of correct and fixed, right? I give that to you in the homework questions, or if it is an exam question, final exam question, then all these numbers are given. So 4 here, and then 3 weeks here, and then 4 weeks here, 3 weeks, and then 0 weeks, right? So if you open the homework question 25, and I also give you these 3 columns. And now we need to fill in the following columns. The earliest start columns, the earliest finish column, the latest start, the latest finish, and finally we need to fill in the flight time column, right? So that's the layout of the table method. Then here's an overview of what we are doing next. Step number 1, we will need to do the so-called downward pass. So that we can fill in the earliest start and the earliest finish, where the earliest finish equals the earliest start plus T. Right. This sounds very familiar because we did this earlier with the box-Nguyen method. In the box-Nguyen method, we draw it from the left to the right-hand side, so we go forward. But in the table method, we go from the top to the bottom. So that's why we call it as a downward pass, right? So that's the first step. The second step is we would go back up doing the upward pass. And the upward pass start with the latest finish date, and then we backtrack to find the latest start date, right? So the latest start date equals the latest finish date, subtract the T. And method number 3, the step number 3 is we would find the slack times, right? Either we take the latest start, subtract the earliest start. We compare the two different start dates, or we compare the 2 finish dates, LF and earliest finish, right? Latest finish, subtract the earliest finish. And then finally, after we do all this, right, we can also find the critical path. Okay, so let's start from the earliest start and the earliest finish to do the downward pass. Then if we look at A, right, there's no requirement before A, so we can start A right away at 0. And it takes 1 week, so we go here by 1 week, right? So A is started right away, and A can be finished at the end of the first week as earliest. By the same token, B can be started right away, and then B can be finished at the end of the 4th week, right? So we have the 4 number here. C is a little bit more confusing because we don't have the arrows to track, right? Then you just ask yourself the following question. What comes before C? A and B come before C. right? So we have to finish A and B before C. To finish A and B, then you look at the end of A and B, right? A is finished at 1, 4, B is finished at 4. So it's natural that we would select the 4 here. So the answer here is 4. We have that 4 because of that 4, right? And we go forward by 3 weeks. So 4 plus 3 equals 7, right? So the same logic as before. It's just that we do not have the visual layout that we saw earlier. Now it's more abstract. We have to get a thing harder about how to go through the table, right? Okay, so now let's do D. For D, you ask yourself one more time, what comes before D? And that is A right here, right? So A needs to be finished before D. So we look at that one, and then we can bring it down here. So we have that one because of that one. And then we go forward by 4 weeks, so we have 5 here, right? So D can be started at 1 and be finished at 5 as earliest. And now one more time, we do the E, then just ask yourself what comes before E. Then A and C, right? Then for that, we need to look at the end of A and look at the end of C. So between 1 and 7, we have to use the larger value. So we have 7 right here. That comes from that 7 here, right? And then we go forward by 3 weeks, so we have 10 right here. I hope everybody sees that, right? And next, we need to do the add. Then one more time, because we don't have the arrows in front of it, right? So we would need to ask the question, what comes before F? So D and E comes before F. It means we have to finish D and E before we start F. D is finished at 5. E is finished at 10, right? So obviously we have to choose 10. Otherwise, we will have a time conflict with E, right? So we choose 10 so that we can accommodate E. It's like we wait long enough for both D and E to be finished and then we can start it right away. So we have that 10 because of that 10. And we go forward by 0 weeks, right? So 10 plus 0, then we have 10. So again, that's the downward path. Like before, that's the forward path, right? Where we fill in the earliest start date and the earliest finish date. Okay, so after we are done with the first step, now let's do the second step where we do the upward. So it's like we're bubbling up in the tank, right? We go from bottom of the tank and then we go bubbling up. Then one more time, we have to impose a condition that we don't want to delay the wedding day at all, right? We want to keep the wedding day at the end of the 10 week. So we fill in that number 10 right here, right? The first thing we do. And then because it takes 0 weeks, so we might try take that 10, subtract 0, then we have the 10, right? Okay, so now going backward without any arrows, without any visual, is a little bit harder. So today, I recommend you to retry this table method right away. Might be several times if you have time, right? So that you gotta grasp it. You are fluent with it. In the past, I allow students to either choose between the box ON method or the table method for the final exam, in the final exam question, right? I would allow you actually for your class if I give you this project management question. I will allow you to choose between the box ON method or the table method. Okay, so maybe in the past some students chose a box Nguyen method, but some others chose a table method. All right, so how to do the E? To do E, then you have to ask the following question: where does E go to? Right. Earlier we asked the question, what comes before? But now we have to ask the question, what does E go to? So E goes to F, right? Because E shows up right here. So E goes to F, which means that we have to finish E before we start F, right? So we have that 10, we start F at 10, and we have to finish E by 10. So that's how we have that 10 right there, right? And then we backtrack by 3 weeks and we have 7. Okay? And then now let's do D by the same token. We ask ourselves, where does D go to? D doesn't go to E, right? D doesn't show up here at all. But D goes to F, right? So before F, we have to finish the D. And F is started at 10. Then as the latest, we have to finish D by 10. And that's why we have that 10 here. And that's because of that 10, right? And then we backtrack by 4 weeks. Then we have that 6. I hope you see that logic. So now let's go back. So that is for D. Now let's go back to C, right? One more time, we have to ask ourselves, where does C go to? C goes to E. So before we start E at 7, then we have to finish C by 7, right? And then we backtrack by 3 weeks, and we have 4 right here. So again, that 7 comes from that 7. And then next, we ask ourselves, where does B go to? B goes here, right? So before we start C at 4, we have to finish B by 4. So we have that 4 because that 4. And we backtrack by 4 weeks, and we have 0. It is the same result that we got earlier. And finally, we ask ourselves, where does A go to? A goes to C, A goes to D, and A goes to E, right? A shows up 3 times. So we have 3 candidates, 4, 6, and 7, right? And obviously we have to choose the 4 p.m. And then we backtrack to have 3 here, right? So with that, by the way, we have that 4 because of that 4. So now we are ready to find the select time, right? So A will have 3 weeks select time, D will be 5 weeks select time, and other activities will have 0. So it's easy to realize that the critical path is also the same as before, B, C, E, F, right? Magically. The methods are different, but then we have the same answer, right? Because we have the same logic and the same project. If we have another answer, maybe we did something wrong, or we alter the project in some way, okay? So again, that will help us to find the critical path, will help us to schedule each of the activities, right? So we are done with the 4 methods to find the critical path. And by now, I hope that everybody is ready with question 25, right? Question 25 and 26 are due next Sunday after the Thanksgiving. So I hope that we have enough time. Today, we're already done with question 25. On Monday, we work on question 26. And question 26 is a very short question, an easy and short question. So you know what? I would like everybody to have a great weekend, and I would like to see you back here next Monday. Thank you all for joining me.
Thank you, Professor. Take care.
All right. Thank you. Yeah.